3.5 differences of means estimation of causal effects using experimental data. Recall from section 1.2 that a randomized controlled experiment randomly selects subjects, individuals, or more generally entities from a population of interest, then randomly assigns them either to a treatment group which receives the experimental treatment or to a control group which does not receive the treatment. The difference between the sample means of the treatment and control groups is an estimator of the causal effect of the treatment. The causal effect as a difference of conditional expectations. The causal effect of a treatment is the expected effect on the outcome of interest of the treatment as measured in an ideal randomized controlled experiment. This effect can be expressed as the difference of two conditional expectations. Specifically, the causal effect on big Y of treatment level X is the difference in the conditional expectations big E of big Y given big X equals X minus big E of big Y given big X equals 0, where big E of big Y given big X equals X is the expected value of big Y for the treatment group which receives treatment level big X equals X in an ideal randomized controlled experiment, and big E of big Y given big X equals 0 is the expected value of big Y for the control group which receives treatment level big X equals 0. In the context of experiments, the causal effect is also called the treatment effect. If there are only two treatment levels, that is, if the treatment is binary, then we can let big X equals 0 denote the control group and big X equals 1 denote the treatment group. If the treatment is binary, then the causal effect, that is, the treatment effect, is big E of big Y given big X equals 1 minus big E of big Y given big X equals 0 in an ideal randomized controlled experiment. Estimation of the causal effect using differences of means. If the treatment in a randomized controlled experiment is binary, then a causal effect can be estimated by the difference in the sample average outcomes between the treatment and control groups. The hypothesis that the treatment is ineffective is equivalent to the hypothesis that the two means are the same, which can be tested using the t-statistic for comparing two means given in equation 3.20. A 95% confidence interval for the difference in the means of the two groups is a 95% confidence interval for the causal effect, so a 95% confidence interval for the causal effect can be constructed using equation 3.21. A well-designed, well-run experiment can provide a compelling estimate of a causal effect. For this reason, randomized controlled experiments are commonly conducted in some fields, such as medicine. In economics, however, experiments tend to be expensive, difficult to administer, and in some cases, ethically questionable, so they are used less often. For this reason, econometricians sometimes study natural experiments, also called quasi-experiments, in which some event unrelated to the treatment or subject characteristics has the effect of assigning different treatments to different subjects as if they had been part of a randomized controlled experiment. The box, A Way to Increase Voter Turnout, provides an example of such a quasi-experiment that yielded some surprising conclusions.